Yeah, started recording itself.
Alright,
We are
cool.
about to start, guys. And if you guys wanna jump in, let's. I'm gonna mute myself. The floor is yours, LJ.
Alright, cool. Alright, so everybody can see my screen, right?
Yes.
Nice. This time I'm actually sharing the full screen. Uh, Alrighty, so we are covering a lot today. So yeah, bear with me. I might have to debug some things because yeah, a lot going that we going over today. But yeah, I already got the licensing set up. I already have the compiler version set up. I have the contract name. I named it function signature. So today we'll be going over visibility of like your function and your variables, public, internal, private, external. We'll also be going over like viewing your functions like with view and purable. We'll be going over payable, overriding your function, setting virtuals to your function, setting the return, you know, setting, returning multiple values, what you can put inside the parameter. We'll also be going through like the constructor, the call method, and a little bit of inheritance. All right. So yeah, a lot of stuff. So yeah, let's get started. So as you have seen in the past sessions, you've already seen public, right? So we'll do a variable in the example in the function example. So uint public number equals 5. We'll do a function example. Function I don't know, random function public. Boom. All right. What's the problem here? Oops. Forgot the parentheses. But anyway, so yeah, if we compile this, right, deploy, and boom. So as you can see, we can view the functions, right? Basically what public does, it does what it says, right? It is visible and you can basically, interact with it, right? Um, so now we'll get into the other visibilities. Say if I make this private now, right? Make both of these private. So I deploy this again, and as you can see, there is nothing here. And basically, what private means, it means what the word is. It is private. You cannot access it. Um, Also, say if you are trying to access this through another function or like another contract, say you are, get like the address of this contract and you are trying to, access this function like this variable is not possible because it is private. Um, there is kind of a way that you can still view um, private variables and like private functions, but I know like you have to go through like using the terminal and all that. It's pretty complex. But if you like a Solidity expert and all that, um, then yeah, you will know how to do that. But keeping that in mind, yeah, usually private you can't view, you know, the value of it. But yeah, just keep in mind that like if you really crack down, you can still view private variables. So yeah, be careful on what you consider private because somebody just might be able to view it if they have that knowledge. All right. Let's see. So next we will be using going over internal. So let's see. I'm going to use this function as an example. So internal, let's see, view returns u. It's gonna go ahead and make this public. All right. Let's see. Return number. All right, there we go. So now if I deploy this, right? So as we can see, number is currently public. Once again, public meaning it's visible to everything, right? So yeah, click on this and you can see 5 and this value and all that. But if you notice, you do not see the random function button. But there is a way we can do that. So this is kind of where inheritance comes in. All right. So we'll do contract. I'll just name it inheritor, and we'll do is function signature. So yeah, this is where inheritance comes in. You use the keyword is for, your contract to inherit another contract. All right. Let's see. So we'll do function view number from contract. Just give it a random function name. Public view. Maybe I could just do this public, and we will do. Let's see. I believe this is how you do it. Function dot random function. All right, cool. So we will deploy this again. And now we have 2 contracts. All right, so now I'm going to hit inheritor instead. Deploy, and boom. If I hit this, oh, let's see. Okay, so maybe I have to do view returns. Let's see. Uint number equals this function call return number. All right, so we're gonna redeploy, and let's see, view number. There we go. So yeah, I just had to set that to uint and put view. But basically what internal is, so like you can't necessarily view it like right away, but internal kind of acts as public when it is viewed by a derived contract, and in this case the derived contract is inheritor. And also I want to say that internal also works when say like this contract function signature. I believe I would say I can use declare a function here where I can also view the value of this, or like what it's returning. So function, I don't know, random function 2 public view returns uint. Let's see. It's, I don't know, I'll just name it number 2
Um,
equals.
LJ, I think you can directly just return that number. Sorry, you can directly return that function, return random function, and I think it's gonna work fine.
Alright, thanks for telling me that.
Yeah, no problem.
Yep, Sahil's right. Um, so yeah, we'll deploy it again. Carrots, and let's see. I believe this is. Oh, my bad. I did the wrong contract. So function signature, deploy, boom. Random function 2, boom. Return 5. So yeah, once again, internal. Um, basically, you are able to a view something internally, and you can. It starts to act as public when you use it in a derived contract, such as when another contract inherits, the contract that has that original function, that has it set to internal. Hopefully that makes sense, but yeah, you can definitely utilize internal when you are like inheriting contracts. And once again, this is using the keyword is. This is how you inherit from different contracts. All right. Uh,
So basically, what internal means is it cannot be called by. Uh, uh, it just basically means it can only be called by other functions of our smart contract or the smart contract which is inheriting that smart contract. It cannot be called by anyone else. It can only be called internally in our smart contracts. And is basically the on line 22, as you can see, we have written inheritor is function signature. So basically, inheritor is function signature means that inheritor smart contract is inheriting the function signature smart contract. And what inheriting means is that all the functions defined in our function signature smart contract we can use in inheritor contract as well. We don't have to define them again. So that's the advantage of inheriting, right? For example, when we create an ERC20 token, we just inherit the ERC20 smart contract by Open Zeppelin, and we use functions defined in that to create our own cryptocurrency token on Ethereum or on any blockchain or on any like on Polygon we can also create tokens. So we use inheritance a lot in smart contracts because we don't want to invent the wheel, right? We can use the already defined functions in our smart contract.
yeah, thanks for the explanation, Sahil. And also something else that people do when they use, I would say, internal and private. Usually they put, I want to say they put an underscore, uh, yeah, on the function. Yeah, this for internal, and say if I did another function, I don't know, another function private. Usually to indicate that that function is private or internal. Yeah, once again, they will put a underscore. All right. So we went over public, internal, private, and so now the last visibility that you will see in Solidity is external. All right. So
Also, I just wanted to add that when we use a function of another smart contract, in the smart contract in which we are inheriting that function. For example, in our inheritor smart contract, we are inheriting function signature smart contract, right? So when we are calling a function from function signature smart contract, what we are doing is we are saying function signature dot and then the call and then we are calling that function that we want to call. So that's the way to call the function which is defined in the smart contract which we are inheriting. And there is also another way. We can also create an instance of that object. Oh, sorry. We can also create an instance of that smart contract, and then we can call those functions directly. But this is fine. We can also do it this way, like LJ is doing. We can name that smart contract and then dot, and then the function which is defined in smart contract which we want to call.
Yo, you can I don't want to try to make this comparison too much, but you can kind of think of it as like JavaScript. So I know like JavaScript, say you are accessing like an API or like a data dot JSON, basically like an object, um, and like there's like I don't know, say one variable name, I don't know, person, and then to access the name of that person, you'll do person dot name, and it's basically the same concept for here. To access that function from outside the, from a different contract when it's inheriting, you do the name of the contract dot the function name. And also you could do, let's see, you can also do function signature. No, yeah, and then if you want to call like a variable and not a function, you do the contract name dot the variable name, and you don't put the parentheses. And then and then inside the parentheses you'll have this function. It doesn't have any parameters, but say if it did, you could put in parameters in here as well, in the inherited contract. All right, hope that makes sense. So yeah, once again, we went over public, internal, private. So the last one I want to go over is external, or the last one is external. Right. So we'll do uint external. I don't know. You know what? Maybe let's do a string this time. So string external greeting equals hello. All right. Oh, what's the problem here? Oh, right. I'm sorry. So yeah, let me do a function instead. So function, we'll do external function, external view returns string memory. Yeah, I'm gonna go ahead and redefine that string variable, but this time I'm gonna make it public. So let's see, string public greeting equals hello. All right, and we'll do return greeting. All right, so we will deploy this, and boom, as you can see, we have external function. You can call it, and you might be thinking, oh, this seems very similar to public, where you can just call it and it's visible. But yeah, let me show something else, right? So we are going to comment this out, and we are going to erase this. So basically what I can do here is that I can put function signature function signature. And basically all I'm really doing, instead of inheriting it, I am, I'm kind of declaring function this contract as a variable, and like I'm kind of renaming it. And yeah, so now that I've done that, I am going to write another function. Let me let me refresh my browser. Remix acting weird on my computer for some reason. Alright, so let's try that again. So function call external function, let's see, public. Alright, let's see. So we'll do string equals, let's see, function signature dot, see what's external function. And I forgot to put the parentheses again. Let's see.
I'm not giving it a name, and they give it a name to the string.
String, I don't know, hello.
Since it's a string, we need to specify the data location.
Yeah, once again, bear with me. It's a lot of topics we're going through here. All right, so let's see. I'll just do view returns string memory return hello. There we go. All right. So now if we call this, so contract inheritor deploy, and as you can see, okay, that's weird. Feel like it should have returned the value. Let's see. Yeah, that's weird. External view returns. Okay, maybe I'm doing something wrong here, but basically what you can do with external visibility. So external is pretty similar to public, except now what you can do is that external, basically an external function, it can be called from another contract. And because this is marked as external, I do not have to basically inherit that contract. What I can really do instead is that I can, basically rename the contract name, and I can declare that function name through, say the contract name dot external function. Say all external really is that function can be called outside of the where the function was defined at, and yeah, you'll see that with the, I know we haven't gone to this, but you'll see that with like interfaces, and when you are trying to use other contracts within your smart contract or whatnot. Yeah. So does anybody have any questions before I go ahead? I know that was a lot.
I just
I
want
have a
to
question.
Yeah.
Do you have to use the public and the can you use the public and the external keywords at the same time?
I would say no.
Yeah.
Because when it comes to external, and this is something that I literally remember when I was messing with external. So you might think that you can use external with doing something like this. You an external number, I don't know, 5 equals 0. And basically I get an error here, right? And the thing with external is that external you cannot, you know, use that visibility in variables. You can only use that visibility when it comes to functions. That's why when I, you know, put in external for this function, I don't have any errors. You can only use external for the function signature, not for variables. So if you want to make your variable visible, you will have to use public and not external. External is for, you know, it's allowing that function to be called from other contracts. So does that?
So
Yeah.
can you use public and that external function though?
You can't use two visibilities at the same time. You can only do one visibility.
Okay, thank you.
Yeah, no problem. All right. Yeah, hopefully
And
that made sense.
an external function cannot be called inside that same contract. So in the contract, in the function signature contract, we have the external function, and this function cannot be called inside the function signature contract because this is marked as external. If LJ tries to call this function inside that same contract, for example, LJ create another function and just call this function inside that function, I believe it will not be possible to call that because external functions are not meant to be called inside same contract. I think it should be return view returns string because our external function is returning a string. You could have directly returned that, but it's fine.
And yeah.
Yep.
So external function is not visible at this
So
point.
basically, an external function is not even visible to the smart contract itself in which it is declared. It is only visible to other smart contracts because it is meant to be called by other smart contracts. It is not meant to be called inside the same contract. That's why it's not visible to that contract. So that's another difference between external and public. Those public functions can be called inside the same contract and they are visible to that contract. But in the case of external, it is different.
Alrighty, so now we will be. I know I have view and pure here, but I guess I can first go over parameters. I'll just create a function. Let's see, function parameters public. So yeah, parameters. You can call it parameters or inputs or arguments. It's basically things that you put inside the you know, any variables that you put inside the parentheses. So let's see. I'm just comment this. So in terms of parameters, you can put in string. Remix acting so weird on my computer, but yeah, string and address. Let's see. uint and integer. I believe, yeah, you can do bytes as well. And yeah, etc. So I don't know, we'll do, I don't know, say uint number. All right, so there's one. Also, you can do, yeah, once again, address, addr, short for address. I don't know, int second number. Yeah, this is basically just an example of you being able to set multiple parameters, right? Multiple inputs inside the parentheses, and we will mark this as pure, and I'll explain pure in a second. Returns uint, I don't know, we'll do something like that. So I'll delete this, and I'll say I want to do number plus 1. All right, there we go. All right, so yeah, those were parameters, right? You can put in, I want to say too, you can do, I believe you could also put in arrays as a parameter, but you will have to store it as memory because arrays use a lot of gas or whatnot. But yeah, let's go through view and pure. All right. So I don't know. I'll create. Actually, we'll mess around with the parameters function. So view, right? So we will return number. All right, so deploy this parameters, and yeah, we're gonna ignore this because I was just showing parameters as an example. But yeah, as you can see, I return number, and boom, I can see the value 5 up here, right? And, public, visible, and yeah, let's pay attention to view. So basically, what view is, all view does, it interacts with state variables, and it can read from those state variables. So, and also when you use view, you're always going to see like a returns, and in this case I'm returning uint. So view, you are you know, you are accessing a state variable such as number here, and you are able to return it and view it, right? And I want to say view, it doesn't use any gas. You're just reading from the blockchain. You're just reading from your contract. Now, if we do pure, so I'm going to explain pure in a minute. All right. So, okay, I guess I can explain this too. So I get an error, right? So it says function declared as pure, but this expression reads from the environment or state thus requires view. So yeah, view and pure, these are used for different cases. So pure does the opposite, kind of the opposite. And pure, you are not trying to access a state variable. A pure function, yeah, a pure when you're setting pure, you are not reading from a state variable. Also with pure, you cannot view the value of a variable. What I can do though to get rid of this error, so we'll just do another random uint. So uint, I don't know, random number equals number return random number. So as you can see, I have the green check mark. So pure is used, so yeah, once again, pure is used when you are not trying to read from a state variable. And really pure is used when you are just, messing around with local variables, right? And if we deploy this again, let's see, I'll just type in a random number. That's weird.
LJ,
Yeah.
can you share your screen at a lower frame rate? I think you're doing it at 160.
I think, yeah, I'm
Yeah.
doing that 1080. All right, I'm gonna decrease it. I'm gonna decrease the quality.
Can you share it at 720 15 FPS?
All right, cool.
Because I cannot see your screen. Yes.
Y'all should have said that sooner. All right. All right, is this better?
Yeah. This is fine.
All right.
Okay.
I think the FPS is the same, only the quality decreases.
Yeah. FPS is still the same.
Wait, but you guys are still able to see it, right? My screen?
Yeah, it is fine. Your screen is fine.
All right, cool.
But I told you to share it at 720 15 FPS, but it's still at 60. But it's fine for me. I can see your screen. Go ahead.
All right. Okay, for some reason, Remix is showing the value of random number, but usually when you have pure, you are not able to, like read the value. So yeah, that's basically view in pure. Hopefully that makes sense. Now we will do payable. So yeah, I'm gonna make a function for that. Function pay contract public payable. All right. Also, I'll create another function where I can read contract balance. Let's see. Alrighty, so we are going to once again deploy this, right? So we haven't gotten to it yet, but this is kind of a global variable address this means the address of the smart contract. And in this case, it is referring to the address of function signature, this right here. All right. And then dot balance, meaning the how much ETH, this contract has. So if we read the balance of the contract right now, it's 0, right? But we have this function named pay contract. So now we'll mess around with this value box here and say, I don't know, we'll do 1 ether, 1 ether, and boom, pay contract. All right, it went through. And now if we read the contract balance, boom, it now has 1 ether. Now this number, it looks crazy, but this is in Way, and Way is 1 ether is 1 times 10 to the 18th of Way. So yeah, that's why it has that insane number. All right, but basically, what's going on here is that all Payable really does, what Payable does is that when you put it in a function signature like this, that allows you to send money to the contract, pay money to the contract. So that's what Payable does. And we'll get to Payable again when I introduce the .call method. All right, so now we will go over override and virtual. These relate to each other. All right, so let me come up with a function. Let's see. Function hello. Yeah, sorry if this is all over the place. So, but yeah, function hello there. Public override view returns, see, string memory return hello there. So yeah, all I'm doing is returning a, let's see what the problem is. Okay, we'll do virtual then for this. And I will explain virtual in a minute. All right, so yeah. So that's a function name, hello there. And let's see. We will inherit this again.
I'm sorry, LJ. Can you please share your screen at 720 15 FPS? I cannot see your screen again.
Oh, I'm sharing
Maybe
the.
it's my internet.
Oh.
Yeah, you're sharing at 720 60.
All right. Hold on.
Yeah. Sorry about that. I think it's with my internet. Can everyone else see his screen fine?
Yes.
Okay.
Yeah.
All right. I'll decrease the frame rates. All right. Can you guys see it now?
Yeah.
All right. So yeah, going back to this. So once again, we are trying to explain virtual and override. All right. So let's see. Inheritor is, let's see, function signature, and we'll do function hello there. Actually, let me just copy this. Let's see. And I'll remove that for now. Or let's see. All right, so basically, wait, let me. All right, so basically what I am doing here, right, is that I am once again inheriting function signature. Yeah, the contract inheritor is inheriting the contract function signature, and function signature has the function name hello there, and I basically copy the same function hello there in this. So we have this keyword named override, right? Override, it basically allows you to take on, use that same function, right, from the contract that it is inheriting, and you are able to re-modify it. You are basically able to, change it up how you want it, right? Um, so now, right now we have an error here, right? So if we go up, um, trying to override non-virtual function, did you forget to add virtual? So now, this is where I explain virtual. Um, Virtual, it just basically means that you are allowed to override this function. So unless virtual is here, um, Solidity, it will not allow me to override and modify this function in, basically the contract that is inheriting function signature. So yeah, that is the um, relationship between virtual and override. So that's what that is. Um, so multiple return values. So also be going over that. Um, let's see. Okay,
Have
so
you covered the dot call function?
no, I haven't gotten to that yet.
All right.
I'll get to that in a bit. So yeah, all we have left is returning multiple values, constructor, and dot call method. So this might take another 10-15 minutes. All right. Function return multiple values. Let's see. Public view returns. Let's see. Events string memory. All right. And return number and greeting. All right. So with the Solidity, I believe we showed this in other sessions, or some of the projects that Sahil was doing. But yeah, basically you can return multiple values in Solidity, and all you gotta do is specify the variables, right? And you gotta of course put a comma when you are setting multiple variables. And I can also do, I don't know, address or bytes memory. So you can return all those types of values. And when you are returning more than one value, you have to put parentheses after return. Also, I believe that you have to make sure that the that like the first value that you are returning, it has to correlate with the order in which you set it here, right? So say if I do, I believe this is the case. So say if I do greeting and number. So yeah, Solidity is throwing an error because it is thinking that greeting is an integer and it's thinking that number is a string memory. So yeah, you have to remember to put it in order with how you assigned it in the function signature. So yeah, that's a little brief example of returning multiple values. All right, so yeah, now we got two things left: constructor and call method. So next we have constructor. All right, the way you initiate constructor is constructor boom boom boom, and we'll do let's see, I'll use address as a parameter or input, give it the name of underscore addr, short for address, and we'll set addr equal to message dot sender semicolon. Let's see. Actually, trying to think if I want to use a state variable. Address public owner. Maybe I'll do this. Uint constructor number equals, yeah, I'll just do that. And I'll do uint number and constructor number equals, what's the error here? Oh yeah. Okay, it's giving out an error because I'm not using constructor and I'm inheriting this, so maybe I should do this. Let's see. Will that work? Yeah, let me just comment this out so they'll stop giving out errors. Alright, good. Alrighty, so now as you can see, now we have these two tabs. So usually you don't see this, right? But because we have constructor, these are now visible. All right, so we'll do, let's see, we'll just play around with this. I'll just put in this address here, and I'll just put in 5. All right, and also keep in mind that this is now currently 0, right? Actually, let me demonstrate that real quick. So yeah, let's see, constructor number. Oh, I didn't make it public. Let me do that real quick. So yeah, default value is 0 for constructor number. All right, so now I'm just want to show that. Now we're gonna bring back constructor. Now these are visible. So boom, and we'll just put in, I don't know, 999 transact. All right, so basically what I did there is that I am setting the values of variables, state variables. Well, okay, this isn't a state variable, but yeah, basically I am giving a value to variables when I deploy this. sort of like initial deployment. All right. And that's all that really the constructor does. It allows you to set the value of variables during deployment. Um, and actually a very popular use case for constructor is this. All right. So we'll do, let's see, address public owner. We're gonna erase these. Owner equals message.sender. So as you can see, I don't have any parameters there because I didn't have any parameters in the constructor. But this right here is a very popular use case for constructor. Basically what I'm just doing is that I am setting the owner to the address that is deploying this contract, and that is basically me. And if I deploy it, let's see, if we do check on owner, boom, the address is me, because that's, you know, the address that I deployed it with. But yeah, very popular use case for a constructor is setting the owner of, you know, the contract. You know, you depending on what contract, depending on what your smart contract does. Say you want to, you know, pause like people, you know, buying crypto or whatnot. You only want the, you know, maybe you only want the owner to do that, you know, and this is a good way of setting the owner of the contract when you deploy it. All right, so that's what constructor does. Once again, you are defining, you are giving values to variables when you deploy it. So, yep. All right, so that's constructor. The very last thing that I want to go over today is the .call method. All right, so we will do the I'm gonna say the syntax of this might be a little confusing. All right, pay person public payable. Let's see. Full success equals. Let's see. We'll do. I'll set. Yeah. I'm gonna set address as a parameter, and we'll do addr dot call value. See, we'll do uint amount. Let's see. All right, good. Oh, also require success and blah blah blah. Actually, let me just write the correct comments. Yeah, let me refresh the browser so that I can reset this the value, or reset the balance, just to better showcase this. All right, so go back here. All right, the function is still there. So now we are going to deploy this. All right. Oh yeah, I need to mark this as payable. Yeah, that's something I didn't mention, but you can use payable as well in the parameter, and this is only for address. You can only mark payable to address, basically meaning that you are allowed to send pay ETH to this address. All right, so let's see, do that, and all right, so we are going to use this. We're going to copy this address to this parameter and say we'll do 100, and 100 in this case would be way, I would say. Actually, let me just do a really big value so that it will reflect. Actually, no, even better. I'll do this. This should work. Alright, good. Yeah, I know we never went through that, but I want to better showcase this. Better, we'll do 10. Deploy. Once again, we'll copy this address. Alrighty, so now just pay attention to these balances, right? So both of them are 99.99, and the reason why that is because both of these contracts were used to deploy the contract, and you basically use gas when you deploy contracts. But anyways, so once again, pay attention to these balances. So when I hit this, oh, there's an error. Wonder why it didn't send. That's weird. Well, let me try that again. Make sure this is right. Oh, yeah, the color. Oh, let's see. Oh, that's why. I didn't, I need to use this. I'm pretty sure that's why it didn't work. Alright, so let's try this again. Once again, pay attention to these balances. Pay person. Alright, now it worked. Alright. So, as you can see, the balance of this went down and the balance of this went up. And basically what happened here is that this contract, or I'm sorry, this address sent 10 ether to this address, and yeah, the balance of this went down 10 ether and the balance of this went up 10 ether. All right, so there's basically three methods. There's three ways that you can send ETH to another person in Solidity. There is send, transfer, and call. Now you probably there are times where you probably gonna see transfer. Send, I'm pretty sure you'll never see somebody use that. But the most used, the most recommended method to sending ether to somebody is the call method. All right. And dot call is basically a low level method, and once again sending ether to somebody. So yeah, I had to mark the function as payable, right? So that I could, send, and also I had to mark this as payable, or else this address wouldn't have, been able to receive the ether. So yeah, let me just reiterate. I don't know what keeps happening, but yeah, let me reiterate this whole line. So first, right, you have these parentheses. So we have bool success, and there will also be another parameter here, or another input, bytes, memory, data. But in this case, we aren't, trying to receive data or anything. So we just need bool success. All right. Um, so basically, you have success here, right? All this means is that it will return either true or false if you know, if sending the ether went through. Um, if this is true, then yeah, it's going to send the ether. But if it is false, then it's not going to send the ether. And yeah, we also have a required statement here saying that success needs to be true. Success meaning the sending the ether has to be successful, or else the log is going to basically spit out this information saying failed to send ether. But yeah, that's Boolean success. That's what that means. And then we set it equal to this. So we specify who we are sending the ether to. So in this case, it is underscore ADDR. And in the example that I did, we sent it to this address here. So we sent it to this address. And that's how now the balance of this is basically 110 ether. So yeah, we specify the address, dot call, you use curly braces, value, the value of, basically how much, yeah, you'll always have to type this in, value, colon, and this is basically the amount that you want to send. So in this case, we sent 10 ether. And this right here, you have another parentheses here is got the quotation marks. All we're doing is, sending ether. So you leave this empty. Not only can call method be used for sending ether, but it can also be used to call other functions, functions outside of, that contract. And yeah, once again, call is a low. I'm not gonna get too much into that, but yeah, call is a low level method. So calling other calling other functions through the call method, it can be dangerous at times, I would say. But yeah, I just want to show this call method because this is a very common way in sending ether to somebody. This might look a little complicated when you are first seeing it, but yeah, you will probably see this often. All right. But yeah, that's call method. We basically went over everything for today. We talked about the visibilities that you will see in Solidity, public, internal, private, external, like the mutability, you being able to view the return value, right, of like a variable, a primitive data type, pure, meaning that you are not reading from a state variable, payable, meaning that, either that address or that contract, receives ether, override, meaning that you can modify a function, virtual, meaning that, that function is allowed to be overridden, return multiple values, send a parameter. Constructor, once again, you are setting the value of a variable when you deploy it or like before deployment. Uh, dot call method, and we, somewhat we basically demonstrated inheritance, right? Where I'm sorry, you use the is, um, where you use is to inherit a function, or I'm sorry, not a function, a construct. Uh, so yeah, that's a lot. Um, I made some mistakes there. I might have explained something wrong, but yeah, we went over a lot today. Um, and yeah, I mean that's about it. If anybody has any questions, they can say it now.
LJ, I have a question.
All right.
So, this in the call method. Can you once show me like to transfer 15 ETH?
Say it again.
No, basically when you didn't give value in the uh, in the left menu, it showed an error, right? Only then you changed it from way to ether and gave that value that got transferred. But in the line 32, we have specified that it should transfer 10 ether. So what's the significance of that? If we are going,
Well, basically, Solidity, once again, it is statically typed, and you want to, like code its law, and basically you want to make sure that you send 10 ether and 10 ether exactly. Actually, a more formal way, a more like dynamic way of doing this would be message dot value, basically meaning that you are sending. So like in MetaMask, like you can choose how much ETH you want to send to somebody. This will basically be that's basically what message dot value is. But yeah, you just want to if the function says you have to send that value, then that's what you have to send. And you know me, I had to send that 10 ether, or else I had to specify 10 ether, or else that basically calling this function was going to fail. But yeah, a more suitable way of doing it will be message.value, because you have more flexibility. You can send any amount that you want to. I didn't want to show message.value because I was getting even deeper into other variables that you will see in Solidity. But yeah, I hope that answers your question.
yeah, it does. But so if now we have mentioned the 10 ether, if we send 20 ether from the left menu, what would happen? It would have any error, or the 20 ether would be transferred.
Can you say that again?
So in line 32, we have specified 10 ether, right?
Yeah.
But when we deploy and when we send the value of it in the left menu, we give 20 ether in that. What would happen?
I want to say that I could be wrong about this, but I'm pretty sure that the function is going to throw this error is going to throw this exception, and Boolean success is going to return as false, and is going to basically return this message saying failed to send ether, because you want to. The function is saying that you want to send 10 ether and not 20 ether. So I'm pretty sure if you send less than this or higher than this, it's going to fail. Yeah.
Okay, got it.
Yep. Anybody else has any questions?
Yeah. if you guys have questions, you can ask in the pair programming chat as well, or you can ask LJ directly now. It's totally fine. If not, I think it's quite late for LJ. We're gonna wrap this up. And tomorrow, Sahil is going to lead a lottery smart contract. Am I correct, LJ?
Yes. Yeah, because tomorrow is day 6, right? Yeah. Tomorrow's day 6. So yep, lotteries, smart contract. And yeah, this is the only thing I want to say. But give me feedback on how I did today, cause I kind of messed up a lot. I kind of messed up a bit, and I know I went over a lot today. So yeah, just give me feedback on how I did today, so I can improve for next time.
Great. Yeah. And also, I mean, since people are joining in for Solidity, so we're assuming people already have a bit of programming experience. So even if you went through a lot of stuff, it's kind of fun. It's not like we were doing with JavaScript, right?
Yeah.
So yeah. I think that's it. Thank you guys for joining, and we'll see you tomorrow.
All right, see you guys tomorrow.
Right. See you guys.